Okay, so we are discussing about a very important concept called OLTP and OLAP concepts. So online transactional processing and online analytical processing. So these were always kept as two different softwares. Now what happens is, like, let's say you have the day-to-day operations of a business. So day-to-day operations of a business always runs in OLTP system. Okay, OLTP is a generic term, OLTP system, online transactional processing, and all the decision making will be happening on the data which is there in the OLAP software, online analytical processing. So now the best example for SAP OLTP from SAP perspective is SAP ECC 6.0, which we had worked on, and SAP S4 HANA suite, which we are working on. So S4 HANA suite is just an ERP software based on HANA database. Now this is the latest one. And then we have on OLAP system, we have SAP BW say 7.3, and then we have something called SAP BW for HANA. This is the latest one, which is based out of the HANA. Now, if you observe carefully, every day what used to happen for us is that we had big tasks like moving this data from this OLTP system to OLAP system for decision making. So the concept was always was that historical data means, let's say, even if it's a 2 years old data, 10 years old data, all this data used to be actually warehoused, parked into the business warehouse software or OLAP software. Online analytical processing is a generic term. Any software which is used for analysis, any software which is used for analysis is called OLAP software. Any software which is used for transactions, any software which is used for transactions is called OLTP software. So OLTP and OLAP, two different softwares were always maintained in two different databases and two different ways of storing the data. Now, what SAP did is, like, they have introduced, such a pattern that they have actually come up with a solution for this. Okay, so how did they do it, and how did they approach is what we'll see. Now, basically, if you talk about HANA, let's assume a scenario wherein, like, we have let's take a scenario wherein an organization, any organization, for example, like, let's say BMW, they have a SAP ECC software which is based on, which is actually working on Oracle database. Now they have this is SAP BW 7.3, and then let's say they are working on, this is working on SQL database. So SAP always maintained till ECC that they can go for any database. Okay, it's a choice of the client which database they would like to choose. SAP used to only provide the software. Okay, and hardware also was purchased by some other companies, from other companies. So what SAP did is they introduced SAP HANA Studio. and which was basically on purely on HANA database. Purely on HANA database. Now, this was way back, I'm talking about way back in 2010. So, what SAP did is, instead of telling to the clients that we already have a database which you on which you need to work on, what they did is they introduced the HANA database for some other concept like HANA Studio without disturbing the existing environment. And this is called sidecar method. In sidecar method, what happened? The software used to be, SAP, what they did is they brought the data from all these different systems, loaded into HANA database, and presented to the client that this is the best way and the fastest way to access the data. They had demonstrated to the clients that this is going to be a very impressive development which actually affects the business very positively. Now, what do I mean by that? They have shown that, let's take an example. Now, they took a scenario where the client is the client is actually waiting for 1 hour to get a particular report. Now they demonstrated through HANA Studio that it will be there, it will be presented in less than a second. So it was a quite impressive, demonstration that SAP did, and clients started slowly inclining to HANA database. Then what they did is they slowly moved this HANA database to BW also. That's called BW for HANA. BW for HANA. So they have even before BW for HANA, they had something called BW on HANA that we'll discuss later. But, so this is the one we have. So these are the databases, these are the softwares and databases that we have here, and they slowly moved this to HANA database. Okay, and so before they make HANA database mandatory, they actually convince the clients that this is something which is very futuristic and something which will be very effective for the business growth. So after establishing the trust of the clients and all, they slowly made this as HANA database. Okay, HANA database instead of SQL database, HANA database. Now then they slowly move to here. They move to BW. First they move to BW on HANA. Then they move to BW for HANA. BW on HANA and BW for HANA. BW on HANA and BW for HANA. Now, going forward, now, then after that, this happened way back in 2012, 13 kind of place, and then 2014. After 2014, they slowly started. 2014 and 15, they started this. They started moving it from SAP ECC to SAP S4 HANA. They always call it as S4 HANA suite. So they moved that, and then when they moved that, it is mandatory for us to move to HANA database. Okay, first they launched a sidecar method, then they slowly moved this HANA database to BW, and then that moved to ECC as well. So this all process took some 5 years, and then SAP said that any company would like to establish, any company would like to get ECC, any ERP software, then they have to go for HANA database. Now, this process had a lot of things that we have to discuss. Then what they did is, see, when we were observing all these changes happening, most of us have guessed that SAP is going to downside this. They are going to stop this BW new versions, and they're going to focus mostly on HANA Studio. That's what was our assumption, because why did we assume so is because most of the features which were there in the BW were actually being launched in HANA Studio. Okay, so we assumed that BW is going to be replaced completely by HANA Studio, but it was wrong. That assumption was wrong. So SAP didn't stop the BW versions. They keep launching new versions in BW, and the latest one is BW for HANA and HANA 2.0. Then SAP HANA Studio is still there. They have not taken away this one. They have not taken away this one. So and the reason for that is what we'll discuss. Now, having said this, SAP didn't stop there now. Let's say we have SAP S/4 HANA, BW, then we have HANA Studio. HANA database. Now, what they did is uh, they launched everything on a single database. Now, individually, there is a time when they had maintained individual databases, but here we have a single database. Now all are pointing to the single database. Now there is no need of moving the data from OLTP system to OLAP system. OLTP system, OLAP system, and the HANA Studio, everything is working on the same HANA database. So this is the present day scenario. And let me tell you that HANA database again had a new version called HANA 2.0. So when we talk about HANA 2.0, it's a database that we are talking about. HANA 2.0 is the database that we are talking about. Okay. So now if a new implementation is done, if a new implementation is done for any companies, it will be definitely S/4 HANA working on HANA database 2.0. But if it's a support project, you might have to support the old version of S/4 HANA or even ECC as well. In some companies, they still have ECC, and we should be able to support that. Now, why we are learning about OLAP system is because now that is also a part of our entire environment. And HANA Studio, whatever we are doing is we are accessing database. But we need to observe that when we are accessing the S/4 HANA and HANA Studio or BW for HANA, we have to see whether it is going into the same database or not. Because sometimes this scenario will be there, wherein databases will be different. Both are HANA databases only, but they are maintained differently, so the data will not be accessible. So we need to be very careful about what kind of environment are we working in. Individual HANA databases or a HANA platform. Now this is called HANA platform. This is called HANA platform because they call it as HANA platform, wherein they can launch not just these three, even a CRM software, supply chain management software, or any software which is provided by SAP is now a part of this HANA Studio, this HANA platform. And they have also acquired, SAP has also acquired a lot of companies, lot of technologies which are based out of cloud. Okay, in the recent times, they have acquired a lot of companies who are based out of cloud. So, and they integrated all those softwares into this entire environment. Fine. Now that's the reason we were talking about OLTP system and OLAP system. Now we also have to understand about the row storage and column storage, which I'll be explaining later. But what is the fundamental difference between the storage of data in the OLTP system and OLAP system is what we need to understand. Now let's assume that someone is entering this data from a screen. I mean, like there is an application where new joins data have been updated into a new application. There will be a screen where they enter this all these things. But then when it stores in the backend in the database, it will be like this. The data will be stored like this. I mean, like data will be stored in the form of a table. So this is assumed to be the best way to store the data. Okay, so this is assumed to be the best way to store the data. But then in 1990s they had challenges, like it was very difficult for the companies to actually manage the data. They can neither throw the data outside nor they can use it. For example, if we take a chain of supermarkets like Big Bazaar supermarket. Now, if it's a Big Bazaar supermarket, if they have sold some, toothpaste in, in 2000, 2020, then that toothpaste information is not required in the OLTP system. OLTP system just needs the transactional data. So once the process is done, business is done, and it's closed, and it's been like 1 to 2 years now, there is no need of that data. But it might be very much useful for decision making. For example, if the person would like to purchase that entire toothpaste company, they'd like to see how many sales they can do in their own supermarkets, right? So in that kind of a scenarios, what we can do is we can go ahead and understand it better by analysis of the data. So how do we do the analysis? By you have to have a tool. So these are the two challenges. One challenge is data storage, and the second one is decision making. Decision making. So for this, in the 1990s, they started something called data warehousing software, and it was started by a person called Bill Inman. Okay. He's the father of data warehousing. So I happened to meet him and discuss with him once upon a time. So okay, so he was considered as a father of data warehousing, but Microsoft does not agree for that. Microsoft claims they are the founders of big data warehousing. But anyways, the data warehousing concept goes like this. See, all the data which we have above is actually stored in multi-dimensional concept. Multi-dimensional sense. Let me show you this. Okay. So let's say we have this and you have city, HYD and bank. So no matter how many times the data is getting repeated in the data, in the actual source data, it's going to store only once. So this process will actually remove the duplication of data. So country also, India will be stored only once. Even if it's repeated million times, it will be stored only once in a particular table. So this is, if you observe, these are all getting stored in different tables, not individual single table. So in a single table, what happens if you have 100 fields, or you might have seen in Mara table we have 300 plus fields, and if you don't fill a particular don't fill all the values, like for example 3 or 4 values have been filled and remaining all are blank, okay, then it's going to consume the entire row. The memory will be allocated to entire row, so lot of memory is wasted for blank fields. But that's not the case here in the multidimensional. Every data is stored only once and each one will have its own table. These are called columnar tables. This is a row storage. This is called row storage. This is called row storage. The first one is called row storage. Second one is called column storage. So we'll have columnar tables, and and how do we actually link? We are not bothered about linking it, since the system is splitting it. Automatically, the system will create its own surrogate IDs. It will create its own surrogate IDs, and this will actually link this. And it will actually system will automatically allocate some number to this. For example, it starts with 02. Let's say if we allocate it 02 here, it will allocate 03, and that's it. No matter how many times it is repeated, it will always give you that value only. Okay, so country will be stored in one table, city will be stored in one table, and each one will be stored in another different tables. This is what we have. Now hope you understood why we are making use of this multidimensional concept. If we go a little further, we have something called star schema. Star schema is more of technically more in detail about the multidimensional concept. So I'm going to explain you about the multidimensional concept, but now before we go, data warehousing we'll have certain things like we'll have types of fields. We segregate the fields. There are a lot of types. So primarily we'll have something called attributes and measures. So attributes can be any characteristic values, but but measures will always be numeric values. Numeric. Now let me tell you an example. Like numeric in the sense, like you can have something like a date. Date is also a numeric, or time is also numeric, or all these things are numeric. Now all the characteristic values which we have, for example, employee number is there, or employee name is there, or department is there. These all come under the dimensions. Employee number, even though if it's a numeric, you can consider it as a attribute. Numeric measures are like date, amount, or quantity, or integer, any time, any integer, or say something like numeric. So these all come under the measures. These all come under the measures. Fine. So these are the different types of fields that we have here. Now, how are they placed in the star schema is what we need to look at. So I'll be explaining about the star schema concept and how it works, and then we will understand the difference between the measures, significance of measures, and attributes. Attributes are characteristic values. The measures which we were talking about are there in the middle. So whatever you see in the middle is called the fact table, and it will have the measures in the sense numeric values. And then this is the dimension, and dimension will have the characteristic values. So these are the characteristic values that we have, and these are the measurements that we have. So the measures will always be numeric values. For example, if you see the customer ID will be numeric, vendor ID or date, revenue, all these are there, which we all have this as numeric values. But the characteristic values will always be surrounded with it, and these are called dimensions. So please remember that the dimensions are there around the fact table. The fact table will have the measures, and the characters will be always there in the dimensions. And dimension tables in HANA Studio are called attribute views. So first and foremost, when we go to the content level, we are going to create the attribute views first. We are going to create this first. And this is called the attribute view, which has all the attributes. And then we have the measures, and the measures will be there in the analytical views. So when we create an attribute view here, and fields or the attributes. Attributes means each field means fields, the characteristic characteristic values. And analytical view will have, this is analytical view. So analytical view cannot be created without measures. So we need to have measures in the fact table, and we need to have at least one dimension. One dimension is one attribute view and one measure. So we cannot create an analytical view without at least one measure and one attribute view. Without this, you cannot create a we cannot create an analytical view. So we need to create an attribute view by taking the fields from the table, and then we'll first create an attribute view, at least one attribute view, and then we'll create one analytical view with a combination of attribute view and measures. This is what we're going to do in the scenario which will follow.